Hello everyone, hope you're having a good break and had a nice Easter weekend. I promised a video to go with the solution I sent out for question 13 from the Mechanics and Stats paper. So I'm going to talk through that solution that I sent out some time ago. So question 13a is just about assumption. 13b asks about the direction it's going. So the velocity, we're told, is minus 4I plus 6j, which looks like that. And the velocity gives us the direction. So I worked out this angle here using tan, and then you've got to remember that the bearing is the angle clockwise from north. So it's 270 degrees plus that angle there. Okay, coming to part C, I was wrong here, wasn't I? It's Cindy herself, not Cindy's puck. Cindy is skating towards the puck and she intercepts the puck. And we're told that her movement is from a starting position of 34.22 and her acceleration is minus AI, which means she's accelerating in the negative x direction. No y direction change at all. Her initial position was 34.22, so that means her y position will stay at 22. Sorry, I've been working on my bike today, so I have washed my hands. There's just a little bit of residual oil there, I apologise. So what we do is we go back to the puck, which started from this position here and has this velocity, and we use this formula, which we sort of discussed. I said it's common sense, but there we go. New position is old position plus velocity times time. And we basically say at what time will the puck have a displacement, a y displacement, the same as Cindy. Now, you might have been able to work out from this just by looking at this that t is 1.5, but it might have helped to sort of separate it into separate x and y equations. So looking at the y equation here, we get that 22 is 13 plus 6t, which is how I know that t is 1.5. And then trying to work out where it is in terms of x, the x position is equal to 30 minus 4t, and we now know that t is 1.5. So that's how we know that when Cindy meets the puck, her x displacement is 24, and that's happened after 1.5 seconds. So we know that Cindy reaches the puck at an x displacement of 24 after 1.5 seconds, but what we're asked in the question is what is the acceleration. So Cindy starts with an x displacement of 34. So by the time she's got an x displacement of 24, she's moved minus 10 units in the x direction. So I'm now just sort of resolving horizontally in the x direction. Time was 1.5. I want to know the acceleration. She started from rest, so I use this and I get my acceleration to be minus 8.89, and so A is 8.89. Now part D made my head hurt. We're told about the goal. Here's one goalpost, here's another goalpost, and looking from the positions, both of these positions have an x displacement of 4, but this one is, I've realised I've got this, oh no, that's okay. That's 14 and that's 12. So the goal is 2 metres wide. And the goaltender is stood half a metre above G2, and she can reach 0.8 metres. So basically she can, I'm assuming it's a female goaltender. Doesn't say, but there we go. We've got, anyway, she can reach as far as this. So basically this is the only space. The top goalpost and this point here, I called it R, which is as far as the goalie can reach. So Cindy's got the puck and she's moved to this position here, and she's going to fire the puck towards the goal with this velocity, and this is a different A to the A in the previous question. And we've got to work out the possible range, the possible values of A. So what I did was I said, right, let's see what value of A you'd need to make the puck hit the goal post here, and what value of A would you need to make it hit this point here. and then anything in between those values the goaltender won't reach. So I started with G1. I said, okay, new position will be old position plus velocity times time. So we want the puck to reach the goalpost, 4:14. This was where the puck started when Cindy hits it, and we're told that this is the velocity. So again, you might be able to have worked that out on your own, or you might have chosen to do separate x and y calculations to get t is 0.25. So I've separated this equation there into two separate equations. The x displacement this time gives me the fact that t is 0.25, a quarter, and from that I can work out the value of a. I then repeat the process for to work out what value of a would make it hit here. So similar sort of calculation, and that means that any value of a between 4 and 6.8 can't be equal to 4 because it'll hit the post and won't go in. Can't be equal to 6.8 because this is the furthest she can reach. So it's anything in between that would be a goal. Now, if you manage to work that out, I'm very, very impressed because it took me a long while and it made my head hurt. But there we go. There's that question. Don't forget to keep in touch and let me know if I can help with any of the questions from the pack of papers I gave you for Easter. Take care.